Hi everybody, I would like to present you the key concept of virtual LAN. So what the hell is it? Take a look. Imagine that you are administrator of A+ cookies company who makes the best cookies in the world. And imagine that you have a 3-floor building. For example, there is a ground floor with IT staff, HR and sales. There is the first floor with HR, IT staff and sales. And there is also the second floor with it. So, what is the classical concept how to interconnect the devices in our LAN or this LAN is that you have one switch per one floor. But there is a very big trouble with it. For example, when you connect these devices to one switch, these devices to one switch, and these devices to one switch, the trouble is that in this router you can't distinguish between the devices. For example, the IT staff are having the common LAN, for example, IP segment. The HR having the common IP segment, and sales also have not the common IP segment. So how to solve it? The solution is a virtual LAN. For example, when you have this switch who are capable for the virtual LAN, for example, Cisco C2600 or 50 or 60, for example, the TT, there is a possible to have logical switches between them. So, for example, in this floor, there is one logical switch for this computer or the IT staff computers. There is one logical switch for the HR computers and one logical switch for the sales computer. So, in this floor also and this floor also. So, there is a possible to logically group computer based on IP segments. And there is no possible, you can't distinguish between them. For example, distinguish between HR or sales. And why to do that? Why you can't segment the networks? For example, why you want to have IT staff in one group and HR in one group and sales in the one group? Why? There is usually for security reason, because there could be, for example, L450, for example, based on source port, destination port, source IP, destination IP, and source destination name. And for example, this L350 or L450, you can distinguish between the logical networks. And the second reason is QoS. You can prefer, for example, top management, and you can go to the background, the HR or sales. It could be very heavy, but it's possible. And for example, have a firewall and have a QoS. The another C or view of the virtual switches and VLANs is in this way. You have one physical switch, but you can have in this switch, for example, for thousands of logical switches. Or also in this example, we have two VLANs, VLAN 10, the blue computers, VLAN 20 in the red computers. And notice that there is or couldn't be together. There is a space between them. So, for example, these computers are in the separate logical switch, and these computers, red computers, are in the separate logical switch. There is no possibility how can this computer reach directly this computer. Just one solution how to do that is to use router. router has a special trunk port. We could talk about it later, but there is just if this, for example, computer would like to communicate with this computer for the blue VLANs to the red VLANs, every single packet must go with an L3 device, for example, this router device. So this topology are called also the router on stake topology, because there is a router on the stake. So, what is the VLANs? Summary. They allow the network administrator to create logical groups. It's also a possibility to logical segment the networks, not based on the physical switch. And it is the main advantage. And there is also use for the geographical structure. For example, you can't have a special geographically places. You are geographically independent. So this is the reason why that do you want to do VLANs. So briefly the benefits. First one is the security. Why? The security is the reason because between the logical switches you can't switch directly, but you must go every single packet through router. So router can distinguish. Yeah. The second is cost reduction, because you should not have many switches. You can have just few switches, and you can do virtual switches with these few switches. So you have less switches, and just you haven't so many switches and so many networking materials. So this is the reason for the cost reduction. There is also the high performance, because the switching between the virtual switches is really faster in comparison with switches in the classical network. There is also the broadcast store migration. What it is? That is just that, for example, every single RRP packet, address resolution protocol, when you can say in the network who has the IP address 1111 or 1112. So this is the RRP when you want to see the RP address, or for example the MAC address. So you can do or RP request, and this is there is a very often. So every single frame, L2 frame, just send it to the FFFF, the layer 2 broadcast packets, are send it to whole physical switches. But when you have a virtual LAN and virtual switches, every packet or every single frame, broadcast frame is just staying in the same VLAN. And there is just also the improve the IT staff's efficiency. Why? Because there is virtual switches. You can do virtual grid. You can do, for example, you can say you are the manager of the company and you say, for example, I would like to have a new switches, new department, please buy the switch. But there is no buy switch. You have switches. You can just create the virtual switch using the Cisco commands. So it's just many efficient, the efficiency of the IT stack. And there is also the simple project and application management, because when somebody migrated the department, it's 100% easier to do with a virtual switch and not with a logical switches. Imagine this example of communication. You have 3 switches interconnected together, and you have one router connected just to this switch. Imagine that the PC1 would like to communicate with a PC4, also the faculty VLAN. There is also the faculty VLAN, but in the different switches. There is no problem. The communication between the faculty PC1 is this way, without the router, this way, this. Yeah? The communication between students are also making this one, this way, this, without router. The communication between guest VLANs, for example PC3 and PC6, is also without the router. But when you would like to communicate between VLANs, you must do it with a router. For example, when PC1 would like to communicate with PC5, there is a student VLAN, there is a faculty VLAN, you can do that just using the R1 switch. I can show you that if would like, for example, this faculty communicate with this student, you can use this way, this way. This switch must to send it to the R1 router and then distinguish. For example, in the L3 of R4 firewall, is that possible that this PC1 could, on this port, for example, in the port and packet, can communicate with this computer? We allowed that before, yeah? Okay. So continue and send this way. Every single packet in this topology must to send it to the router to distinguish. Okay? This is the communication between them. So, how to interconnect the switches? You can to do the classical view. For example, there is two switches and every single VLAN have special interconnection. For example, the number of VLAN equal the number of the interconnection, but it's not possible to do it in the real situation because you have, for example, 4,000 VLANs. And it's not possible to have 4,000 interconnection between every switches. For example, you have 48 port switches and you have 4,000 VLANs. It's not possible. So, what is the solution? The solution is use logical separation between them and using just one connection. And these connections are called trunk. So, it's enabled to passing multiple VLANs traffic. And the membership of the VLANs are sent into this one link to logically distinguish between the VLANs. This is the trunk link. And you can say, yeah, this is the corporate standard, but you can say, oh my god, but for example, when the mouse comes here and cross the cable, we are out, we end. But it's not possible. It's not possible because, for example, this physical cable you can multiply it, for example, 16 times. So you have, for example, 2 times or 3 times or 4 times, or for example, up to 16 times you can have this one cable to multiply. So it's not possible. For example, if you have 2 or 3 or 4 cables, it's enough to have redundancy or failover. That is the trunk encapsulation types. You have 2 types. How to just one moment. How to package the packets in this communication. The first one is Cisco interswitch links (ISL), and the second is 802.1q. The first one is classical. For example, you have a data frame. We talking about the layer 2 frame, and you have just encapsulated about the header and about the checksum. But it's too slow. It's too slow to our topology. So I have two devices, for example, also in the home from Cisco, and I would like to connect it with the ESL. Today is not possible because whole Cisco doesn't support fully ESL and Cisco proprietary standard. World standard is 802.1q, where just inside the tab to the packet, you have this L2 frame with the destination address, source address, and there is a data frame with the L3 frame, and between the L2 and between the L3, you just insert the tag. And this tag consists of this is 16 bits, and it's also with a VID. VID is a VLAN ID who identifies the VLAN. For example, there are just 0 to 4096 options on 95 option because a 0 is included. Yeah? There is 4096 opportunities how to segment the networks. But be aware, because the cheapest devices than Cisco can have also just 255 options of VLANs. So be careful with the compatibility in the real world. I would like to heartily thank you for viewing, and I would like to hope the video is informed for you.